Okay, hello everybody and welcome to our new webinar about AI, data centers and global warming. In the past few years, the data center industry has witnessed a major change in the global compute capability, with an increasing shift of workloads from on-premise infrastructure to the cloud. A new study revealed that data center computing output jumped six-fold from 2010 to 2018. With a general energy consumption rise of about 6%. In 2030, the energy consumption related to internet traffic is expected to increase to 21% of the global power consumption. And 5G is going to be one of the main drivers of the next data explosion, as everybody's calling it. Given that picture, how can the data center industry limit its energy consumption and consequently mitigate its impact on the environment? Maybe AI is the solution we are looking for. And behind me, you can see one of the major supercomputers based here in Barcelona, where our headquarters are, which pretty much does a lot of that. Moving maybe to the next slide, a brief introduction of myself. I'm your host for this session. My name is Daniel Pope, for those of you that don't know me. And I'm the CEO at Submer and co-founder together with Paul Biles. I started working in the data center industry at a very young age, the age of 16, literally. Maybe not so much the data center industry then, because I started it with a server in my bedroom, as a lot of you know. But in all those years, I was lucky enough to see some major technological achievements, such as, for example, virtualization and the evolution towards a resilient software stack in the data center. But I've also seen things you people wouldn't believe, to quote a famous movie. I've seen data centers still relying on old models and ideas that are far from efficient and sustainable. That's when Paul and I decided to create Submer, a deep tech company where our ambition is to transform data centers into smart lights out, immersion cooled data warehouses driven by robotics. And immersion cooling is just the first step, the first building block of those next generation infrastructures. You can obviously reach out to me at any time over phone, email, Twitter, LinkedIn, whatever. The webinar will be available, of course, on YouTube channel, where you can also find all our previous webinars, and you should follow us on social media to remain updated about Submer's news. You can also find us on Applecast, Spotify, Simplecast, and SoundCloud. So I think we're on every single damn platform out there, no excuses. We've reserved 10 to 15 minutes for QA at the end of the session, together with Matteo Mezzanotte, our PR and communications manager. We will address as many of your questions as possible, but please type your questions into the QA section and we'll get them out there towards the end. Without further ado, I'm delighted to introduce you to Alex Palladini, our esteemed special guest for this session. Alex is an audio technologist, singer and composer with 14 years of experience in audio technologies, software engineering, strategic research, and music production. He holds a PhD in information engineering, and Alex has been recently appointed Chief Research Officer at Music Tribe. Alex has strong expertise in advanced signal processing, machine learning, and AI technologies in the context of audio and biomedical products like ultrasound imaging, brain-computer interface, dialysis systems, etc. In January 2020, at the Data Science Conference 5.0, Alex presented The Dark Side of AI, Psychology of Automation for Data Scientists, a reflection on how to deploy machine learning and AI models into products used by experts and creatives. Alex, welcome. Anything you'd like to add?
No, I think it was a pretty good introduction, and yeah, I'm a musician. If you can see my video feed, you can guess that because of the amount of gear I've got here.
Yeah,
And
I guess I expect you're going to play something for us at the end of the webinar, no?
well, I'm a singer, so I might sing something. We might make a song just for this, for data and data centers and global warming.
Awesome. One question from my side to kick it off.
Sure.
Why, when we think about AI, our mind thinks about Terminator exterminating us? Is AI a bad thing, or what is it?
Well, I grew up, with those movies, Terminator, Robocop. So I also like sci-fi. I'm a big fan of Isaac Asimov and so on and so forth. So I get the hype for the negative side of AI, but I'm probably over positive about it because it's my passion, and because I believe it's going to be the next technology, for the next 20 years. It's going to change the way we live. So I think there's a lot of risks involved, like in any technology, but a lot of opportunities. And I always prefer to focus on the opportunities, and of course leave the concerns to the policymakers, to make sure we don't, make too big mistakes like we did with other technologies in the past. So I'm over positive.
Thanks, Alex. Well, the floor is yours. Go ahead, and looking forward to what you're going to explain.
Thank you. So, well, welcome everybody. Good morning for who's on the other side of the ocean, or evening for who is in Asia, and good afternoon for Europe. I'm going to start, with this slide, which is pretty pessimistic. Starting with, the kind of this the core of this seminar, which is about global warming. And I'm not an expert of global warming, as I'm not an expert of most of the topics I will talk about today, but I believe they are crucial topics for us, for our future. And that's why I decided to create this webinar and structure it this way. So global warming is a concern. There are still people believe that it's not going to happen, it's not going to affect us, but the vast majority of the scientific community agrees that it is going to have a huge impact on our lives if we don't take measures. Data centers, of course, might seem, only stuff for geeks, but it's not. Data centers are a key technology for our society. Pretty much everything we do these days will go through a data center. That's a fact, whether it's a mobile call or an interaction with a payment, and anything really, a flight, everything goes through a data center. And so data center are going to be another core technology for our future. And 5G, of course, is a controversial topic, mainly because I want to say the media and the way it's being depicted in the media. But we all know it's going to create huge opportunities for us and also concerns. And finally, of course, what I don't want to say I'm an expert, because it would be an overstatement, but definitely AI is my biggest passion and also the field I work in. And I, as I said at the beginning, I believe is going to be one of the key technologies for our future. So, all these things together, might seem completely unrelated to each other. But what I want to do today is try to take you through a journey where I show how actually these things are also interconnected to each other. So it might seem, a lot of buzzwords, but there's a lot of ramification to all of these concepts and topics that I'll take you through. First of all, before we start, I wanna discuss something with you and discuss about complexity, because very often the truth, which we are so obsessed about, is far more complex than we think. And the biggest enemy, especially when we tackle complex topics like the one I want to talk about, is simplification. And we all know that there are people that believe the Earth is flat, or actually they believe that coronavirus has been caused by 5G. And so it's very easy to fall into the trap of conspiracy theories and in general, following misinformation rather than information. So how do we go about tackling complex topics without falling into these traps? Well, first of all, good sources, I would say, always first and foremost, but more importantly, something that I want to talk about before I start, which is scenario analysis. So complexity is best tackled through scenarios, not through just a series of forecasts. So what is a scenario? A scenario is a narrative, which consists in a series of factors that interact together over time So we can start with a very small set of assumptions, but these are going to expand the possibilities they're going to create. And the interaction of these factors can generate multiple solutions, multiple possibilities, and all this in a probabilistic sense. So none of this is guaranteed to happen, and actually might be different. But why is this useful? Because it helps us to address the complexity of the reality that we live in, and also to overcome the myopic view of forecasting, which is actually a tool that is used a lot. And I'll show a lot of this. So today, I'm not going to give you any answer because I'm not in the position to do so. But what I want to do with you is to create a few scenarios about the topics, the factors, 5G, data centers, AI, and global warming, and 5G, and see how they are all interconnected, okay? So let's get started. So let's start with global warming. Global warming is the first example and the best example of how simplification can lead us to wrong conclusions, false conclusions. There's no easy fix for it, I'm sorry. It's not me who decided this, but it's actually science. And what I'm referring to here is a paper from 2018, which is a great start if you want to get familiar with the concept of scientific studies around global warming. And basically what it shows is that it's not one fix, one solution that's going to mitigate it. It's not just changing your diet or stop taking the plane or actually reducing the emissions. It's the combination of many different factors, and in particular, how we use energy, how we use land, and the emission altogether. And actually, the scientific community studying global warming created a scenario framework. So going back to scenario analysis, where different factors, energy, land use, and emission, interact, and they create different possibilities. So I just took a picture of this paper, which shows what this means. So we have time here. So we are actually here, 2020, and these are the emissions we have created so far. On this axis, you got the carbon dioxide emissions. And this is how the future could look like, depending on different scenarios, so how we combine the different factors. From now until 2100, which is our reference time, because by then, we know that the temperature, if we don't take any precaution, the temperature of the world might rise so much to cause catastrophic consequences on our environment. And these are, this is trajectory pretty much if we won't do anything about it. And these reference scenarios, so it's not one possible, it's a set of them. And these below, which look more optimistic, are actually different type of scenarios combined together where we actually try to mitigate the consequences by playing different factors. So what are these factors again? As I said, energy, which is probably one of the most important one, shifting away from fossil fuel, of course, and try to make our energy as green as possible. So these are some of the key things that might give us, with a good probability, only 60% actually, which is not great, an increased temperature below 1.5. And so these is 3 papers that I really encourage you to go through, because they opened my eyes on the complexity of the problem and actually inspired the whole journey that I'm taking you through. So what about data then? If energy is so important, what does this have to do with data? Okay, well, it's very simple. If we look at the energy forecast and how we use energy, even just 5 years ago, this rainbow here is the ICT industry. So the whole thing together, which comprises networks, the production of ICT equipment, consumer devices, and data centers. And we can see that based on the analysis that were referenced also in the introduction of the webinar, by 2030, it will be about 8% of the global world energy, but in the worst case, it's going to be 21%. So in a matter of 10 years, we're going to increase significantly the amount of energy we use. And this is because of the increased population, of course, but also the emerging technologies, and in particular, the internet explosion, more data. And if we look at the breakdown of this growth, we see that whereas right now it's quite balanced, towards 2030, it's going to be heavily influenced by networks, wireless networks, and data centers. And that's very important for us, of course. So you might have seen some of these, in the news, some of these headlines like the tsunami of data. They could consume up to 1/5 by 2025. Now, of course, some of these forecasts are a bit off and over negative. The reality is that there's a lot of things going on in the data center technology, and it's not just about AI, of course. And actually, everybody, it's in everybody's interest to make them more efficient, as efficient as possible. And there's been already huge progresses compared to the analysis done 10 years ago, which looked really daunting. But the reality is that we're not going to decrease the amount of data we're going to send around. Actually, some forecasts, show us that by 2025, we might be producing 175 zettabytes, which is 10 to the power 21, which is astonishing. And if you see the growth in just 10 years, it's exponential. So we are actually basically creating more data as we speak. And that, of course, leads to 5G. So what has 5G to do with this? Well, 5G is just one of the many evolutions of mobile technologies. Some of you, and certainly myself, started with 2G. I briefly saw 1G, the analog mobile network. And what is interesting beside the technology and the name is that as we go up and we pass from generation to the other one, the speed of the connection, of the data connection increases. From few kilobytes, which were not really great for browsing the internet, to a few gigabytes per second, which is what we have now, or even more, which is actually where we consume most of our internet traffic right now. And 5G is just going to be one of the pushes. In 10 years from now, we'll probably be talking about 6G, where the frequency and the bandwidth is going to be pushed toward terabits per second, which is astonishing. And this is going to open up new scenarios. 5G certainly is going to enable the IoT promise. So a world of devices interconnected to each other, always connected and always transmitting and receiving data. And in 2030, around that time, 6G is going to deliver something even more interesting and exciting, which is a full intelligent connected system. But what are the implications? Well, first of all, 5G is going to take off quite quickly. And some of the forecasts say that by 2025 is going to be already 15% of global mobile industry. And the number of connection is going to increase quite quickly. So this is in billions. So we're going to reach 3 billions very soon. A lot of devices. And then, of course, more devices means more interactions. And I found this metric quite interesting, the interaction per capita per day. So a measure of how much we interact each day. And you can see, again, the trend is exponential. Why? Thanks to the new technology, thanks to 5G, which is going to make the number of interaction we have even bigger than the one we have now, because it's not going to be limited to our mobile devices anymore. It's going to be everywhere. So, of course, more data, you get the idea, more energy. And so this is another article that kind of from 2019, which goes through some of the potential implications that 5G might have regarding energy consumption. So you can see there's way more concern than just the health concerns that we need to take into account. And so finally, AI. What has AI to do with all this? It seems that we're talking about energy consumption. Well, what we know is that artificial intelligence is going to be the future. I truly believe that. And actually it's going to be probably in the next 20 years, invade every space of our lives. And this raises a lot of concerns, of course, especially from an ethical point of view, from a human point of view, but first and foremost, from an energetic point of view. And actually, this is a paper from 2009 that created really a tsunami in the community, which kind of exposed the carbon footprint, the energy footprint of machine learning. What we have in this table here is some of the key NLP. NLP stands for natural language processing, which is basically the branch of machine learning that studies language text. So chatbots is one example of application of NLP, for instance. And these are the key benchmark algorithms. Some of them are very simple and others are groundbreaking algorithms that are ubiquitously used. And if we look at the cost in terms of hours of training, or power, or even better, kilowatts, PUE, which takes into account also the inefficiency of the equipment that is used to run the algorithms. So you can see this number is far bigger than just the power used to run the algorithm on its own. They are astonishing, and the carbon emissions even bigger. And not to speak about the costs, of course, to train this algorithm in the cloud. Some of them are in the order of millions of dollars, of course.
So I wanted to stop you there a second, Alex,
Absolutely.
and so there was an article out there put out by Anders Holowitz I think a few months ago now,
yeah.
which was really trying to share some light and at least explain the challenge that a lot of the AI startups are having with not having forecasted how much training an AI module algorithm costs, right?
Yeah.
Using these cloud infrastructures or the cloud providers to train their AI algorithms has proven a challenge, and a lot of startups have actually they've had financial challenges because of that. What is your take on that?
Yeah, you are absolutely spot on. And actually, this table gives you a glimpse of that, depending on the complexity of technology that might be required to solve your problem. Because let's take a step back. These startups usually try to tackle a problem, to solve a problem by using machine learning or artificial intelligence, right? So what they need is clever algorithms to do things, and it could be anything really. And depending on the complexity of your problem, the cost could be $100 of bucks to millions. And that's where the estimation you were talking about when you do your budgeting can go completely off. And that you always have this choice between completely self-service cloud infrastructure, which costs a lot actually. And actually with the company I work for, we are discussing this topic as we speak in my team. Should we switch to cloud? Because we back then, when we started 4 years ago, we decided to buy some servers, which costed quite a lot of money. And of course, we have to maintain them as well. So it's not just the cost of the hardware, but it's the total cost of ownership of infrastructure can be really big as well. So it's always hard to tell what is the best solution is. And certainly, cloud systems can be very easy to use, off the shelf almost, I want to say, but it can be extremely, extremely expensive. So even just storing the data can be extremely expensive, and that's where usually a lot of the money go, not just in the training, but also storing the data, the bandwidth. So there's a lot of aspects to take into account. Does this answer your question?
Yeah. Absolutely. Yeah. Thank you, Alex.
Yeah. So going back to the carbon footprint, I just want to spend one more minute on this slide and just look at this number, because of course they don't mean much unless you have a reference. And if we go on this table here, we have actually a reference and a comparison between the carbon footprint of some training for some algorithms, and then a car, including petrol for a lifetime, not of a person, of a car on average. So you can see that some of these algorithms are actually having a bigger impact in terms of emission than cars, or the average American, the average human on Earth. So that's quite shocking, of course. So, and the trend, going back to your question, Daniel, it's not going to get better. Actually, we can see that the complexity of the algorithms and the required, training, it's going up exponentially. And actually, it doubles every 3.4 months, as far as this paper from 2000 and I think in 2019, OpenAI, in which they analyzed the trends from 2012 until now. It's really, really worrying. And actually, some people say, well, this is the end of deep learning. We can't scale. We need to change the paradigm. So, of course, yeah, again, a lot of power. Can we really afford this? The ICT picture I showed you before with the energy consumption didn't take into account machine learning. Maybe it's another 10%. Who knows? So there's a lot of concerns and question marks there. So to wrap up, to summarize, the scenario I built almost leads to AI at the top, which is going to drive a massive energy consumption, by means of data centers, and data in general. The edge network, 5G are going to make this even worse. So a lot of energy making everything worse. But that's just the scenario, right? What I did here is that I took a lot of headlines and scientific papers, which are real, not made up, put them together in a narrative to create concern, to create a possible scenario. And it's not to scare you, but it's just to reflect on what are the possibilities, right? And I've not been very scientific about it, but I kind of at least give you an idea of what could happen. But now I want to change the paradigm, and I want to challenge you and say, what if we flip the pyramid and actually AI, that's my challenge, is going to be the base for a reduction of emissions. Why? Because we're going to tackle all of the worries that we discussed before, one by one, with AI. Is that possible? Well, let's see. So first of all, accuracy in machine learning is one of the key metrics that we have been using for years, and I'm a big advocate of not using just accuracy for many different reasons. And one of them is, well, we need to start taking into account efficiency. Efficiency from many different points of view. It could be how efficient the algorithms are when they are deployed, but also how efficient they are to train. And you can see that in most of the conferences, accuracy, which is the red bar, is still the main feature, but you can see that efficiency and other metrics are starting to crop up. And actually, since, again, 2019, actually, most of the paper or the articles I'm referencing here are not older than 2 years, which is interesting, on its own. This paper, Green AI, created a big, which was triggered by the previous one, a big movement of, in the machine learning community, awareness of the footprint or energy footprint of the algorithms. And now, a lot of researchers are starting to advocate the use of other metrics, like the one I showed. And there is even a PhD thesis published in March, which, addresses directly the problem of how do we go about using AutoML, which is, again, AI, training AI, so to speak. So techniques to automate completely the process of training algorithms, not only to get the best model, which is usually the goal of AutoML, but to get actually efficient models that are ever better with respect to these metrics like carbon emissions, electricity usage, and so on and so forth. So there's something happening clearly there. People are responding to this. And the second, help we can have is can come from tiny AI. What is tiny AI? Well, it comes from the fact that the devices that are used to power, to train algorithms are tiny, very small, but very powerful. And they can be embedded in any device in the future. So what this means is that we could start training models not only in the cloud, but have a kind of a federated approach where we have also edge devices like mobile phones that can run algorithms, train algorithms, and improve the performances. So there's no need for data centers anymore, maybe in 10 years or 15 years from now, to train models. We could use other type of paradigms and again, reduce the energy footprint of data centers or the strain. I mean, data centers are not gonna disappear. They're gonna be there for other reasons, but machine learning push can be also moved elsewhere. And what about connectivity? Well, it just so happens that machine learning is gonna be one of the key technologies behind the spectrum allocation for 5G and future standards. And actually this challenge that was created by the Defense Advanced Research Project Agency, which is an agency in the US that kind of is responsible for the spectrum allocation. And they created a challenge to use machine learning to improve the spectrum allocation. What this means is that we're moving away from fixed allocation of frequencies, which is usually done by governments, and we hand over this to algorithms that can optimize this by increasing the capacity of the network, but also the energy consumption, can be decreased, which could be revolutionary. And then, I touched briefly on 6G, and 6G actually is going to be even more interesting because it's going to be a 3D networks, a network of networks, where we're going to put together, the terrestrial network, which is the mobile network we know as we know it now, with satellites, at different altitude, or even vehicles in the air or at sea. But what is interesting is that all this is going to be driven by artificial intelligence to make sure that the capacity of the network is suitable, and also that we can actually have a less energy consumption and so on and so forth. And you can see by the title of this paper, there are already topologies and architectures to make sure that the network consumes the least amount of energy possible. So again, the community is responding to the concerns about energy, and actually it's going to be part of the standard most likely. And finally, we are at data centers. What about data centers and AI? And probably here more question will flock. There's a lot of literature about it, and I'm not an expert on how to use AI in data centers, but I can see where the whole trend, the whole industry is going. And this article, just elicits 5 different, major contributions that machine learning could have for data center management. And some of the most intuitive are cooling, of course, which is a huge issue, but also capacity planning. So why do we keep servers on all the time, or virtual machine on all the time? What if we could allocate where the machine runs, or if the servers are on and on at all, dynamically based on the forecast that we have of the traffic of the usage. And other applications, are like risk analysis, to prevent downtime, of course, of facilities, and so on and so forth. But you can see there's a lot of work being done also in kind of research. This is a PhD thesis published 2 years ago, and specifically targeting resource management for data centers. So there's a lot going on. And of course, it's not just research, it's reality. We know that Google claimed that by switching to a completely self-managed data center, they're saving 40% on the cooling bills, which is astonishing. But of course, we don't have to stop the cooling. We can go to the whole management and have completely autonomous data centers, which seems to be the future. But again, I'm not an expert, so some of you might be able to elaborate more on this. And is data centers the only thing we can do? No, actually there are companies like the startup in Montreal, Brainbox AI, working on how to manage a whole building. So the cooling, electricity for a whole building by using AI again. And this can of course push the consumption of energy further down and allow us to have greener buildings, which is another important topic. So if we go beyond, of course, buildings, what do we have? Smart cities. Smart cities are cities which are all interconnected, and 5G or 6G are definitely gonna accelerate the trend. Right now, the biggest impediment, of course, is to have connectivity everywhere. But these new technology, are promising us this, and we might be able in the future.
I guess, Alex, the challenge is everything needs to be software defined, right?
Yes.
So that's the journey that we're on, and that's what we see also in the data center industry, where at least Submer's vision is to really enable automation in the data center industry, thanks to having things that are today done by humans, done by machines, which means they're driven by software. And I guess smart cities is exactly on the same journey, of course.
Exactly, just to a larger scale. I mean, I really like the progression, from data centers to building cities. And then the next iteration would be, okay, what I just said before, we put all these technologies on top of it, cloud, 6G, the edge, and AI is going to drive all of this. So we kind of, it seems like the world is building an autonomous network where everything is interconnected and everything is intelligent and can interact. And this, of course, is very, very visionary, but also very real. It feels to me it is very real. We're really accelerating the pace. And it might not take so long to achieve this goal for some of the modern cities. And of course, the opportunities are huge. And the complexity also is huge, which raises, of course, a concern, the whole problem of control. We basically, I've been bragging about AI everywhere for 15 minutes probably. And, some of you for sure are probably, shaking and say, okay, but what if we lose control, And this is one of the topics I care the most about, how, the human factors and the implication of automation. And this book by Stuart Russell is really a book I advise to read everyone. It's called Human Compatible. It's again to show how the community is already tackling the problems, of control of AI. And, the scenario I depicted is wonderful, but we know there could be catastrophic scenarios, and actually somebody else already kind of addressed this in a movie many years ago. But this is a topic that deserves, in my opinion, a whole other talk, which I would be very happy to give. So to wrap up, then, I think hopefully, I hope that after this bombardment of information, you now know more a bit about all these topics and also see how they are all interconnected. So algorithms, wireless networks, data centers, and global warming are definitely going to play a crucial role in the future. And they are all actually interconnected. And what is going to be the real scenario in the next 10 years, 20 years, nobody knows. But I'm hoping that this is going to inspire you to drill in any of these topics. Mine is AI. Some of you might be passionate about 5G or data centers or global warming itself. And I'm really hoping that collectively, we will find technologies that will help us to face the big challenges we're going to have in the future. And that's everything for me. So
Thanks,
it's
Alex.
time for questions.
Yes, and we have quite a few. So, so Ottavio Portalupi is asking us, do you think quantum computing will help mitigate consumption issues? How does it fit in the consumption ecosystem?
That's an amazing question. Yes, I completely neglected quantum computing because it's a huge topic on itself. The challenge is there. I mean, I've been hearing about quantum computing since my master, so middle 2000. And the challenge there is reproducibility. What I mean is we have a lot of possibilities already, theoretical and also practical, but the hard truth is that some of these technologies are still very unstable. But we have seen in the last couple of years, Google declared quantum supremacy, which means that at some task they can outperform it with quantum computing. So who knows? It might be really around the corner. And definitely the energy consumption could be reduced. But as far as I know, actually, at the moment is the opposite. The quantum computers still require a lot of energy resources to be stable. But this is where I'm out of my comfort zone, and I'm not sure, what the trend is going to be. But definitely that's another trend to follow, because if that takes off because of the performances, the energy footprint might be unpredictable, I would say.
So I'll have to figure out how we're going to cool quantum computers with immersion cooling down the road. That's going to be a challenge, I think.
Indeed.
A couple of questions from John Laban. Hi, Alex. We assume that machine learning allows us to more effectively manage hardware or run hardware. So servers, physical hardware. What can you add to the conversation in terms of hardware dematerialization?
Okay, well, yes. I mean, one of the trends, of course, is new hardware architectures that are becoming leaner and leaner and leaner, more efficient. Like the OCP, the Open Computing project. Where the hardware is being stripped down to the bare minimum, and actually, with a more efficient footprint in the hardware, we can also have a better management with software. So there are huge opportunities there in the synergies between hardware and software. And actually, I came across papers where there are algorithms to dynamically decide where a VM should run to minimize the heat transfer. So a system that is aware where most of the heat is in a rack, and decide where the VM should be run in order to have a uniform distribution of heat as well. So the more the software is aware of the hardware and the more advanced the hardware is, the stronger the synergy will be. That's what I think.
And that really connects well with John's next question, which is how important will open source technologies, software, data, and hardware be to the future of IoT and smart cities?
I think it's going to be crucial, because the only way we can really have a major difference is that if we commoditize green solutions, like in the hardware and in the software, everybody will adopt it. There are no reason not to adopt these solutions if they are cheap and if they are ubiquitous. So I think it should be our first concern to make sure that these technologies are available to everyone, especially to the developing countries, which might not be yet willing or they can't afford perhaps to have the cutting edge solutions. So the more they can grab for free, the better. So in my opinion, is crucial.
Absolutely agree there. And what's your take about the dangers represented by AI? Years ago, Hawkins and Musk expressed their concern about the implicit dangers of AI. What's your take on that?
Well, as I mentioned at the beginning, at the end of the webinar, the problem of control is actually one of the most interesting, and actually the effect that automation has on humans, which is beyond AI, it's immense. And we all know, let's just think about self-driving cars. How a self-driving car is going to change our behavior, behind the steering wheel as we rely on more and more automation. My take is positive again, because we have proven record that a lot of technologies we introduced didn't make us dumber. They made us actually more efficient, more effective. They expanded the possibilities. The biggest danger, of course, like in any technology, is misuse. And one of the biggest threats, of course, of AI is surveillance and privacy, So I think this is an area for policymakers. And I believe that, especially in Europe, there's a lot of concerns and a lot of things are being discussed as we speak. And then there are also a lot of foundations like OpenAI, which are contributing significantly to make AI, again, more accessible, more transparent and safer. Another thing I wanna reference there is the importance of explainable machine learning. And what this means is that there's again a movement in the community to push to models that can be not only be efficient but and accurate, but also explainable. And if we focus on that, on explainability of machine learning models, and we have strong design frameworks, so user experience focused only on AI systems, which is one of the areas of research I work on, I believe the future can only be bright. But again, that's the optimistic scenario, and there is always a negative one to take into account.
So Alex, I think the final question would be, do you think AI is going to replace humans one day?
Well, this is this concern we had, as humans since the invention of technology. I think it's not. I think AI, like other technology, are going to change the way we live and the way we work, the way we think. But that's the history of humans. I don't think human beings are ever been, completely decorrelated from technology. Technology, it's one of our biggest achievements. So AI is not going to replace humans, it's going to certainly augment them, together with many other technologies that now we can't even imagine, and are going to be very, very important in the future.
Thank you very much, Alex. I think it's been an incredible webinar, very, very great presentation and conclusions. Once again, if you want to stay updated about Submer's news, we suggest you subscribe to our YouTube channel and follow Submer on social media. And of course, I would also like to remind you about our ebooks that we put a lot of effort into. Here in the picture, you can see the first one, the 3 W's of immersion cooling, but we've also released a new series entitled The 5 Pillars to Build a Smart Data Center. And I hope you enjoy that read. And Alex, I'm sorry, but I mean, it's actually been a request also in the Q&A. Yeah. People want to see you leave this webinar playing something or singing something. So thank you very much, and definitely see you next time.
Yeah. Okay. Well, I don't know what I can sing though. I have no music here to accompany my singing. So
okay, we'll invite you back very soon, and definitely you won't get away with it then.
Yeah. Well, I'm happy to perform live next time with a bit of preparation. But if people want to reach out to me, I mean, here we got some references, of course, for you to grab. But I'm very happy to engage with people. So these are my Twitter and LinkedIn accounts. So just feel free to reach out, and I'll be happy to answer more questions, of course. Thank you, everyone.
Thank you for your time, Alex, and thank you everybody for joining. See you in our next webinar soon.